Hello and welcome to the first of our synthesis tutorials in VCV Rack doing actual types of synthesis. We're going to start with subtractive synthesis, which is probably the easiest because it's probably the most familiar to most students. This is the type of synthesis you've probably heard already on lots of recordings for pop, hip-hop, rock. It's ubiquitous. So the function of subtractive synthesis is to create a complex and interesting waveform and then use a filter to remove parts that we don't really care for. And it's really easy to do this. So I'm going to start off here with some basic things that I've already preloaded. I have my MIDI to CV and my Audio 8 pre-configured, and I have a scope for us to use to view the waveforms if necessary. But let's get to it. So in order to create the basic subtractive synthesis, we need an oscillator, an envelope generator, an amplifier, and a filter. So I'm going to start off, we're just going to use the basic VCV modules, although for homework assignments for my class, you do have to find your own modules for these, but we're just going to start easy. So I'm going to grab a oscillator. I'm going to grab the ADSR envelope generator, an amplifier, and last but not least, I'm going to grab the VCF or voltage controlled filter. And let's start hooking things up. So the way that we're going to do this is we're going to take volts per octave from the keyboard and send that to volts per octave input of the oscillator. Then we're going to take the gate output of MIDI to CV and connect that to the gate in of the ADSR envelope generator. And just for good measure, I'm going to connect retrigger as well. The envelope output of the envelope generator is going to go to the control CV input of the amplifier. And that's going to go completely black, meaning that the level is totally off. Then from there, we're going to send the output of the audio signal into our filter. And then for our filter, we can send that out. So I'll show you the low pass version. I'm going to send that out to Audio 8. And then I'm going to hold down Command and duplicate that cable and connect it to output 2. So 1 and 2 are going to be my left and my right. This does have quite a few other channels. I've got 8 outputs, so I could go to any of those, but you'll only be able to hear it from 1 and 2. The last thing I need to do is I need to hook up the output of the VCO to the filter via the amplifier. So we're not going to do this with the sine wave, and the reason for that is that the sine wave has no overtones. So it's not going to be a good target for filtering. So instead, I'm going to use my sawtooth wave. I'm going to send that to my VCA, and then that's going to the VCF. I'm using the low pass, so anything that is below the cutoff frequency will not be filtered and will pass through. So here's middle C. Okay. And there is nothing going in there. Let's try that. All right, so yes, it helps that if I select my correct MIDI device. But we have a very quiet signal. I'm going to boost my sustain. But that doesn't really sound like a sawtooth. And the reason why is that my cutoff is pretty low. It's just about middle C. So if I take that down even further, we get silence. But if I open up that cutoff, I'm starting to get more of the harmonics coming through. And I can view that by connecting the cutoff to something, but specifically I'm going to connect the output to the scope, and then we'll take the cutoff And I'm going to make this much easier to do so that I'm not having to move the knob like crazy. I'm going to connect that to the output of the envelope. And remember, I can stack cables infinitely. So what's going to happen is I'm going to take the cutoff frequency down by about 50-ish%. And it's going to sweep this knob down. I'll do it with the attack long, so it's going to be a little bit on the slower side. And then as I release, it will go back up to the top frequency. Another way to look at it, if I disconnect that, is if I just reset this. You can hear how that filter is affecting the sound. So that's basic subtractive synthesis. And at this point, if I wanted to use this, say, as a bass, all I would have to do is maybe make it a little bit more plucky with the envelope. We'll take that down, boost my sustain, take my release down, and go down a couple octaves on the keyboard. Or if I wanted to play it up in a higher register, I might want a longer attack and release time. And of course I can play around with the filter and get that where I want it to go. The other thing I can do is, of course, I can add an effect. So we're just going to reset the filters, and I'm just going to search for a reverb. And we're going to use, we'll use the reverb from Surge. So I will connect left and right from the output of my low-pass filter. And then I'm going to connect that to my audio out. Okay, so that sounds a little bit better, but that would be how I would create a very, very basic subtractive synthesis patch. This could work very, very functionally as a bass. Again, if I go into the lower octaves, and then play around with the reverb a little bit. The other thing I could do, of course, is I could change. I'm going to turn off the reverb here. I could change from a low pass to a high pass filter. And I do that just by grabbing these cables here at the low pass filter output and switching those to the high pass. So what's the difference? Well, if I play it right now, my cutoff is set to 2700 plus hertz. So playing middle C, we only have those really high harmonics coming through. You can see that on the scope. But moving that around with the filter allows me to get more of them passing through. Now, the other thing that we should talk about is the resonance and the drive. So the drive is going to add or subtract gain. And of course, that can overdrive things on the filter. Some filters will have that, some will not. However, they will almost always have resonance or res or Q, whatever term they decide to use. And that is providing a slight boost at the level of the cutoff frequency. So here my cutoff frequency is middle C. As I increase the resonance, there's a slight timbral change. And in fact, if I keep increasing it, then even without playing, it starts to self-oscillate. So that can be used to add just a little bit of boost right at the cutoff, and then you have a steeper slope afterwards for the filter. But yeah, if you go too high, you will get whistle tones, and that will happen on most filters, and especially on the physical filters of the actual analog synths that we have in the studios. So just be aware of that. But that's just a very, very basic way to create a basic subtractive synthesis patch that you could use for whatever you so desire.